Hello and welcome. Today we will see how to use dynamic animation in the WinCC. So dynamic animation means how to show rotating object in the WinCC. So what we will do, we will go to the WinCC. So from the toolbox, we will go to the graphics option. From the graphics, from the equipment. So here we can select these four agitator and also for we will take these four blur objects. So here we will take one more blur and one more agitator. So here if we show these objects one by one, so it will look like that object is rotating. So how to show that? So if we assign some integer or word and if we pass the value 1 2 3 4 5 after some time in the sense after 1 second or after 500 milliseconds, so these values will be updated and based on these values we can show the respective object so that it will look like this mixer is rotating, and same thing will happen for these blowers. Okay, so what we will do, first we will generate a PLC code so that we will pass some value into the integer and we will update it after 200 milliseconds or 300 milliseconds, and we will pass these values to this respective mixer or to respective this blower. Okay, so now what we will do, we will go to the PLC. Here we will use simulation. So here we have to show animation for two objects. So what we will do, we will use function block so that same function block can be used for this mixer as well as this blower. So now let us start. So we give the animation control to that particular B. So here we require one timer. So here we will take one timer. So we will give the name pulse and data type it should be T on time. So pulse dot T on. So here input we have to assign and this PT we have to assign. So in the input, when our output will get on, so this pulse timer it should get on. So in the output we will take out. So what we'll do, from this function block only we will start and stop that respective object. Command okay. So when out, here also we have to give pulse time. The data type should be time. So here we have to assign pulse time to the PT. Pulse time. So this timer is ready. So in the input, how many objects are there, right? So here there are 4 objects, 1 2 3 4, and this object we will show when output is off. So that means 0 1 2 3 4. So we require that integer to move from 0 to 4. But here what we'll do, we'll make it customized. Maximum step, and in the output we require step, so that we can pass this step to that respective object. So here what we will do, if out is true, if out is true, then else. Here if pulse dot q is on, then step, we have to increment this step. Step is equal to step plus 1 semicolon and if. Okay, so instead of out we can use some memory bit, so that we can make the timer on and off. So here instead of out, what we will do, we will use memory bit. So initially it should be off. So when memory is off, timer will start. When timer will start, step will increment, and here we will make memory true, memory bit true. Okay, so now here again we have to do if step is greater than maximum step count, then step should be 1 again, and here end if. So So this guy we can put here. So when output is on, our whole this code will execute. So pulse timer, memory pulse time, if pulse is on, step is equal to step plus 1, step is equal to maximum step. When step is greater than maximum step, step will be 1, then memory will be true. When again it will get off, if we make it here, so here we should keep our memory false so that our output will not continuously, so this output pulse, it will not continuously get on. If we put this memory is equal to false here, then our output will get continuously on. On means it will flicker. Okay, so now this thing is ready. So if out is on, then this will run, else step is equal to 0 and if. Okay, so if command, then out is true, else out is equal to false. So what we'll do, we will download this code into the PLC. Okay, now what we will do, for now this FB is ready. So what we will do, we will use this for agitator. So initially we will check it first, otherwise so now let's say our pulse time we set as a t hash 1 second and maximum step count it should be, let's say 4. So if we give command okay, t hash 1 second, okay, no, here we have to force t hash 1 second. Okay, it is updating the value properly. Okay, so what we can do, we can again use for blower. So we will download it into the PLC. Now it's time to give animation. So here when that step is 1, we will make it visible this. When step is equal to 2, when we will make enable this. When step is equal to 3, then we will make this enable. and when step is 4 we will make this enable, and when step is 0 we will make this enable. Same thing we will do for blower. So we'll go for animation. So display visibility 1, and we will give the agitator step. When step is equal to 1, this guy is enabled. When step is equal to 2, this guy is enabled. When step is equal to 3, this guy is enabled, and when step is equal to 4, this guy is enabled. And when our output is off, then this gray object, it will be enabled. Okay, so now we will align those objects so that it will look like it is a only one object. Okay, so now this is ready. So same thing we will do for blower. Blower step 1, 1, 2, 3, 4, and this guy when blower is off, that means 0. Okay, so what we'll do, we will align like agitator. Now what we'll do, we will give command. So simply we will, what we'll do, we will set bit here, agitator command. So name here we will give off. In the same way we will do for blower. set bit. Here we will set bit blower command, and here we will reset blower command. So we can add animation for button also. It is not that much required, but here, so when value of out will be 0, it will be gray, and when value of the out tag turns to 1, button will turn green. So for this also, blower, and here control appearance, agitator out, and this guy green. So now it is ready. So now let us see. PLC on. So here T hash 300 ms, T hash 300 ms, milliseconds, and maximum step we require 4. So it is now we will go to the PNCC and we will put this thing in simulation, and we will start runtime. Okay, so this is not giving clear rotation. So why this is? Because let me tell you. So scan time of this, whatever tags we have attached, so scan time for that respective tags, it is 1 second. So we have to make it less than 1 second, so that, so we will check it to 100 milliseconds, and for the same, for the blower also we will make it 100 milliseconds. So our rotation animation, it will be clearly visible, as because we have set the 300 milliseconds in the PLC. So here we require scan time below than 300 milliseconds. So again we will start runtime. So now see, you can clearly see the rotation. Here also for the blower, you can very easily see the rotation. If we change the time in the PLC, then this rotation, it will be slower or faster. So what we will do, we will go to the PLC again, And here what we will do, instead of, so below 100 milliseconds we should not go, because it will skip that acquisition cycle of the HMI. So here we will do 200 and we will download. See, you can very easily see this rotation. If we change this pulse time, T hash 1s for agitator, and let us see that rotation, it will be slower than the earlier. Okay, we have changed it for blower. So see, the rotation of the blower, it become a slow. Now if we make it as it is earlier, T hash 200 150 ms and download. See, so in this way we can do dynamic animation for the mixer and blower. So in this way there are a lot of objects where we can provide dynamic animation for the motors, for the pipes, pumps, okay, for the tanks as well. There is a dynamic levels we can show here. See this thing, so we can attach this integer, our step value to these 4 objects, and we can show it animated. Okay, thank you.